This is number 4 on the 2009 AP Calculus AB free response question. This is one of the basic area volume question, and it happens to be one of the non-calculator problems. So if you look at the graph, there are two lines. The top line is 2x and the bottom line is x squared, and it intersects at points 2, 4. Part A asks to find the area of R. This part is pretty simple. All you have to do is take the integral from a to b of the top curve minus the bottom curve. So as you can see on the graph, the top curve is 2x and the bottom curve is x squared. So it's the integral of a to b of 2x minus x squared dx. We know that our limits are 0 to 2, looking at the x-axis. So we just plug in the limits, 0 to 2, of the integral of 2x minus x squared dx. Now we integrate this to get 2x squared over 2 minus x cubed over 3 from 2 to 0. And we can simplify this by crossing off the 2's, so we can get x squared minus x cubed over 3 from 2 to 0. The next step is to do f of b minus f of a. So you plug in 2 and 0 in the equation. When we plug in 2, we get 2 squared minus 2 cubed over 3, which equals 4 minus 8 over 3, and which is equivalent to 4/3. So that's when we plug in 2. And when we plug in 0, we get 0, because 0 minus 0 over 3 equals 0. So our answer would just be 4 over 3. So that's our answer to part A. The next part is finding the volume when we know the cross-sections. We're not rotating anything here, so we just know what the cross-sections look like. So part B says the region R is the base of a solid. For this solid, at each x, the cross-section perpendicular to the x-axis has area A of x equals sine pi over 2x. Find the volume of the solid. So to solve this problem, you have to know this equation, the integral from a to b, a of x dx, where a of x is an area as a function of x. In this case, we are perpendicular to the x-axis, but if it said perpendicular to the y, then we had to change it in terms of y. So when we plug in our numbers, we know that our limits are 0 to 2, and they give us our area, a of x equals sine pi over 2x. So we just do sine pi over 2x dx. So now we have to integrate sine pi over 2x, and to do this, we can use u substitution. We can set u equal to pi over 2x. And then you get du as pi over 2 dx. But in the problem, they only want dx, so you divide each side by pi over 2, which is the same thing as multiplying du by 2 over pi. So you can bring the 2 over pi to the outside, so you get 2 over pi. The integral of sine is negative cosine, so negative cosine pi over 2x from the integral of 2 to 0. Now we have to do f of b minus f of a, so we plug in 2. When we plug in 2, we get cosine of, which is, so the 2's cancel out, and cosine of pi equals negative 1. Negative 1 times negative 2 over pi will just give you 2 over pi. So this is our answer when we plug in 2. If we plug in 0 into this equation, we get cosine of pi over 2 times 0. And this goes away, so cosine of 0 just equals 1. So negative 2 over pi times 1 will give you negative 2 over pi. So since we're doing f of b minus f of a, you do 2 minus pi, 2 over pi minus negative 2 over pi, which will give you 4 over pi. And that's our answer to part B. For part C, it says another solid has the same base R. For this solid, cross-sections perpendicular to the y-axis are squares. Write but do not evaluate an integral expression for the volume of the solid. So to do this problem, you'll have to know that the equation to find the cross-section of squares are the integral of area squared dy. Notice that I wrote dy instead of dx because it says that the squares are perpendicular to the y-axis. So since it's perpendicular to the y-axis, we'll have to make the whole problem in terms of y. So instead of this line being y equals 2x, it would be equal to x equals y over 2. And this curve, instead of it being y equals x squared, it would be x equals square root of y. So now we'll just have to plug in what we know into this equation. So our limits, instead of being 0 to 2, it would be 0 to 4 since we're looking at the y-axis. So the integral of 0 to 4, and the area, to find the area, it would be the right-hand curve minus the left-hand curve. So unlike part A, when we did top minus bottom, it would be right minus left. So square root of y minus y over 2. So square root of y minus y over 2. And don't forget to square the entire thing, dy. So we don't have to evaluate the integral, we just have to write it. So this would be our answer to part C.